All right, guys. Let's look at this here. Chapter 6, Exponential Functions and Sequences. Now, the first thing we're going to look at is exponents. Now, there's two main exponent properties we're going to look at first, and then we'll look at a few more here in a minute. Now, the first one is our zero exponent. Anything to the zero power is 1. So no matter what it is, anything to the zero power is always going to be 1. And our other one is anything to a negative power. If the exponent is negative, we move it from the numerator to the denominator. So 4 to the negative 2 is going to be 1 over 4 squared. Now, if we had 1 over 4 to the negative 2, since it was a numerator, we moved it to the denominator to make it positive. We can also move it from the denominator to the numerator. Anytime we have a negative exponent, we move it either from the top to the bottom or the bottom to the top. We're going to move it in one direction or the other. All right, let's look at the first one. 6.7 to the 0. What would 6.7 to the 0 power be? Okay, 6.7 to the 0 would be? For any non-zero number, a to the 0 is 1. Anything to the 0 power is 1. Yep. 6.7 to the 0 power is 1. Anything to the 0 power is 1, except for 0. 0 to the 0 is undefined. So this here, 2 to the negative 2 to the negative 4th power. Well, to make the exponent positive, we would move it from the numerator, because it's in the top, to the denominator. Because if we have a negative exponent, we move it from the top of the fraction to the bottom, or the bottom to the top. Anytime we have a negative exponent, we're moving it from either the top of the fraction to the bottom. If it doesn't have a fraction, we're moving it to the bottom. So really, I'm going to write this back. As we know, if there's not a denominator, it's understood to be 1. And because the exponent is negative, we have to move it underneath, which would give us 1 over negative 2 to the 4th. Now, the 2 is still going to be negative. It just changes the sign of the exponent. Whenever we move it from the numerator to the denominator or denominator to the numerator, we're just changing the exponent. So only the exponent would change from positive to negative or negative to positive. Now we would need to do negative 2 to the 4th. So negative 2 to the 4th, it means we're multiplying negative 2 by itself how many times? 4 times. Well, what is negative 2 times negative 2? Because negative times a negative would be a positive, yes? 2 times 2 is? Almost. Because our other negative 2 and negative 2 would give us 4. And 4 times 4 is? So negative 2 to the negative 4th would be 1/16. Try typing in negative 2 to the 4th, negative 4th, in your calculator. So type in parentheses, negative 2, close parentheses, to the negative 4th, and see what you get. Mm-hmm. So parentheses, -2, close parentheses, our exponent, -4. And we get 1/16? Yeah. Mm-hmm. So for both of these here, the calculator can do these. Mm-hmm. 1/16. All right, 2.5 to the 0 is anything to the 0 power is 1. Anything to the 0 power is 1. How about -3 to the -2nd power? Did you do it to the -2nd? It has to be -2nd because that is our exponent. Now is if the exponent is negative, to make it positive, we have to move it from the numerator to the denominator, which would make it -3 squared. Mm-hmm.
Oh, I was thinking that, like you didn't choose.
So whenever we move an exponent from the bottom of the fraction to the top, or the top of the fraction to the bottom, whenever we move it above or below that division bar, the exponent goes from positive to negative or negative to positive. It goes in one of those two directions. So here, because the exponent is negative, we moved it to the denominator. We moved it down so that it would become +2, the +2 exponent. Because now we have 1/-3 squared. Well, -3 squared is -3 times -3, which would give us 9. So it would be 1/9. Questions on this here? Okay. -9 to the 0 power. This would just be 1. How about 3 to the -3rd? 3 to the -3rd. Mm-hmm. One over 27, yes. Because if we did this by hand, what we would get is we would move it to the denominator, which would be 1/3 to the 3rd. And 3 to the 3rd is 27. Questions on this here? Let's look at number 3. -5 to the 0 over 2 to the -2. Okay, yes. So -5 to the 0 would be because unless they put parentheses around that, the 0 is only with the 5. It's not with the negative. Now, what did we say about negative exponents? I would move it up because anytime we pass that division bar, go either coming up or going down, the sign of the exponent changes. Since it's negative in the denominator, I could move it up to the numerator and make it positive. So anytime we move a number from above to below or below to above that fraction bar, it changes the sign of the exponent from positive to negative or negative to positive. Well, we have everything on top now. So we have -1 times 2 squared. Well, what is 2 squared? 2 times 2 is? So this would be negative 4. Try typing it in to the calculator. So you hit the fraction bar, negative 5 to the 0. So over 2 to the negative 2. And we can use this here. Same thing. Questions on this here? Simplify the expression. Write your answer using only positive exponents. So we have 4x to the 0 over y to the negative 3. Okay. Well, we have two things that we're going to do. One of them is, well, we can only have this with positive exponents. Do we have any negative exponents? Well, yes. We have y to the negative 3. Yes? So if I want to make that exponent positive, what do we need to do? Move it up. And if I move it up, we'll have 4x to the 0, y to the 3rd. So we move it up, and the exponent became positive. Do we have anything left in the denominator? Well, not besides 1, right? So we don't have to put anything there. Is there anything else I can do? What is this? What do we have? X to the, anything to the 0 power is always, so this becomes 1. So we have 4 times 1 times y to the 3rd. Well, what is 4 times 1? So make sure that 3 is up a little bit higher. Because when we write exponents, we want to make sure that it's a little bit smaller and up high, signifying that it is an exponent, because we don't want it bigger, making it look like a number. All right, let's look at this one here. Okay, so what do we know for sure? What can we do? So we can move it to the top, yes. So we can move the y squared to the top, so we get 2 to the 0. X squared, and then we would have y squared. Is there anything else we can do? A to the 0 is? Yeah. So 2 to the 0 is 1, so we have 1 times x squared, y squared. Yeah, that'd be it. We have everything simplified because we don't have anything to the 0 power, and all of our exponents are positive. That's it. Questions on this here? Get what? From here to here? Well, what's 1 times x squared? Okay, what do we need to do? So where are our negative exponents? On top, yes? So to make them positive, we got to move them. Because we're either going to move them from the bottom to the top or the top to the bottom. So since 3 is to the negative 2 on top, we'd move it to the bottom to make it 3 squared. Since x to the 5th is negative on top, we would move it to the bottom and give us x to the 5th. Now what's left on top? So it's automatically what? In fractions, whenever we move stuff like this, 1 is always what's going to be left if we move everything out.
So if everything's at the top,
Right. And we don't normally write division of 1, but if it's on top, we have to write it. Okay? So the numerator is still going to be 1. Can I do 3 squared? Can I take 3 squared? What is 3 squared? 3 squared would be 9, because 3 times 3 would give us 9. We have x to the 5th and, well, wait a minute. What do we have here? Y to the, which is just 1. Well, 1 times anything, so 9x to the 5th times 1 would be 9x to the 5th. Okay. Any questions on anything we've done so far? We're good with these here? Yes? Okay. Now these here are some properties of exponents. Multiplication. If the bases are the same, then we add the exponents. So if the number that has the exponent with it are being multiplied and they are the exact same, then we add the exponents. So 4 to the 6th times 4 to the 3rd, 6 plus 3 would give us 9. For quotient or division, if we're dividing like bases, then we subtract. Then we would subtract the exponents. And our last one is power of a power. Power of a power. These multiply. We multiply them. Well, let's look at the first one here. This isn't in your notes. But what they said is 4 to the 6th times 4 to the 4th. So if I look at these here, 4 to the 6th times 4 to the 4th. Well, according to what we just saw, according to this property here, since the bases are the same, the numbers that are the base, the bottom number, are the same, we add the exponents. That's what the property says, yes? Okay, well, let's see how this works. 4 to the 6th means I'm multiplying 4 by itself how many times? 6 times, yes? Okay, I'm going to write that out. 1, 2, 3, 4, 5, 6. Okay. 4 to the 4th says what? I'm multiplying 4 by itself how many times? 4 times, because it's to the 4th power, yes? So I'd have 4 times 4 times 4 times 4. Okay? And right, and they're all being multiplied together, yes? Well, how many times do I have 4? 1, 2, 3, 4, 5, 6, 8, 9, 10. Wait a minute. 6 plus 4 is 10. When the bases are the same, those bottom numbers are the same, and we're multiplying, we can add the bases. So we look at this here, 3 squared times 3 to the 6 to the 2 plus 6, which is 3 to the 8. Now, in your calculator, go on and do 3 to the 8th. What do we get? 6,561. Okay. Questions on this here? Are we good with this here? This kind of makes sense with the addition. Now, they also said if we're dividing, okay, then we do what? We subtract. So, if I look at this here, negative 4 to the second power means I'm multiplying negative 4 by itself twice, yes? In the denominator, we have it 7 times. 1, 2, 3, 4, 5, 6, 7. Okay. So we have this here, yes? And anything divided by itself is what? 1, yes? So these would simplify to 1. And these would simplify to 1. Because there's nothing left in the numerator, it becomes 1. Now, how many do I have left in the denominator? 3, 4, 5. So really, this is negative 4 to the 5th power, yes? Mm-hmm. Yes, but we have to be careful, because which one is bigger? Is it bigger on top or on bottom? So it would stay on bottom. It would stay on bottom. And I'm going to redo this one here in a minute so we can kind of see how this works with the formula. Now, what is negative 4 to the 5th power? Negative, so it would be decently big. $1,024. And that would be it. Negative 1,024. Okay. So any questions on this here so far? So I'm going to look back at this property. Because with division, a to the m over a to the n is equal to a to the m minus n. This is what the formula says. This is what the property says. So if we use that here, well, this would be negative 4 to the 2 minus 7. And what is 2 minus 7? Almost. It would be 5, but it would be what? It'd be negative 5. And for us to keep a positive exponent, we've got to move it to the denominator. So it has to stay in the denominator.
So if you want to turn
Right. And some of the ways that I look at it is, okay, so we subtract it. 7 minus 2 is 5. Is it bigger on top or on bottom? Bottom, because 7 was on bottom, so it stays on bottom.
it's bigger on top.
Then it stays on.
So it would
Yes.
basically somehow you're going to move the amount.
Right, because if the bigger exponent was on top, it would be positive, which would mean it would have, we could leave it there. But because it's bigger on bottom, and we get a, which has to move to the, and that's it. Questions on this here? And the last type that we dealt with is powers of powers. So if we have, so like this here, d to the negative 3 to the fifth. Powers of powers multiply. And the reason we're saying this is because the fifth power outside means I'm multiplying this by itself 5 times, yes? That means I have d to the negative third times d to the third times d to the negative third times. Yep. Because if we did it this way, it would just be negative 3 plus negative 3 plus. Well, 3 plus 3 plus 3 plus 3 plus 3. 3 plus 3 is 9. Plus 3 plus 3 is 6. Plus 3 is 9. Plus 3 is 12. Plus 3 is 15, and it would be negative because they're all negative, yes? What's negative 3 times 5? Or what's 3 times 5? So negative 3 times 5 would be negative 15. Wait a minute, that's the same thing, isn't it? Because we could have just multiplied them together. But we're not quite done because it is what? So we have to move it to the denominator. Questions on this here? All right. 2 to the third times 2 to the fifth. What would we do? 2 to the, well, 2 to the 3 plus 5, which would be 2 to the, which would be 256. Could we plug 2 to the third times 2 to the fifth into the calculator? What would it give us? Mm-hmm.
That's the same thing like
How about this here? So we would subtract them, yes? Since they're dividing, we would subtract the exponents. So 4 minus 2 is? Would it go on top or on bottom? Because which has the bigger exponent? So it stays on bottom. So we'd have negative 7 to the second, because 4 minus 2 is 2. And since it's bigger on bottom, it stays on bottom.
Wait, if they have
Yes.
the last one,
For A, see? Since it's multiplied d to the negative 3 by itself, so we have that. So essentially when we applied that, multiplying it by itself 5 times, we resolved the parentheses, and we could get rid of them.
so it doesn't, you don't really need the parentheses when you're just unless you're dividing them?
If it is positive. Now here, and so we're saying we're multiplying negative 7 by itself how many times? Twice, yes? So, go on and type it in. So this would be 49, yes? Type in negative 7 squared without the parentheses. See what it says, negative 7 squared.
Negative 49.
Negative 49. Because what the calculator is doing is squaring the 7 without those parentheses and not the negative. Because what it sees without the parentheses, so if it's just this here, what it thinks it's saying is negative 7 times 7. It's squaring 7, not the negative 7. It's squaring the 7, not the negative. So if it is in those parentheses, we want negative 7 squared. Huh? So here, when it's squared it, it's looking at it like, well, I need a little more room. Because without the parentheses, when it has it like this here, really what it sees is this. It sees the 7 being squared, not the negative. So if we want negative 7 squared, we need those parentheses because we want negative 7 times negative 7. Does that kind of make sense? Yeah. If there's a negative, we really want to keep the parentheses. If you're not sure, should I keep the parentheses or not when multiplying or especially plugging it in, keep them. Because there's nothing wrong with having them there. Okay? So this would be 149. Z to the 4th to the negative 3rd. Can we plug this one into the calculator? This one we can't plug in. Because unfortunately, the calculator has to have a value for variables. It has to have a value for the variable. Because it's not to the 0. Now, powers of powers multiply. So we would have 4 times negative 3. And what is 4 times negative 3? It would be negative 12. And because the exponent is negative, we have to do what? Put it in the denominator. And we have this here. Because 3 times 4 would be 12. And we moved it to the denominator because it was negative. All right. Let's look at these 3. So the first one, because the bases are the same, we can add the exponents. So this here would be 10 to the 4 plus negative 6. Negative 2. 4 plus negative 6 would be negative 2. Well, the exponent is negative, so we would move it to the And 10 squared would be 10 squared is 100, so we would have 100. Or the 1 over 100. So since it's asking for the answer in simplest form, simplify the expression. It's going to want you to simplify the numbers all the way down. All right, let's look at this here. X to the 9th times x to the negative 9th. Well, we would add the exponents, yes? So that'd be x to the 9 plus negative 9. So it would equal 1.
So, since you said we have to simplify every equation, does that mean, like, as for our older equations, we have to, like simplify them to the answers too?
If it is a number, then we would simplify them all the way down.
Like this one, we would have to simplify them.
Right, it would be 149. Okay, let's look at this here. Well, wait a minute, they're not in parentheses, are they? So negative divided by negative is a positive. So these here, really what we can see this as is negative 1 times 5 to the 8 over negative 1 times 5 to the 4th. So these here, this -1 and -1 would simplify to 5 to the 8th over 5 to the 4th. So the negatives would simplify because they're not in parentheses, they're not being put to a power. So it would be different.
On this one, you would just
So we can subtract the exponents, yes? 8 minus 4 would be? Is it bigger on top or on bottom? So we leave it on top, so it would be 5 to the 4th, which is 625 over 1, or we can just say 625, because there was nothing left on bottom of the fraction. It would just be 625. Right, we didn't have to move it. It's over 1, but we don't talk about a division of 1. We don't have to state division of 1 if the 1's on bottom. It's understood. Okay, we're going to stop here for today, and we will finish these up to